right, here we go. Question number 19 from our Precalculus homework number 2 in MyLab Math. Another word problem. We have a suspension bridge with weight uniformly distributed along its length, has twin towers that extend 65 meters above the road surface and are 800 meters apart. It says the cables are parabolic in shape and are suspended from the tops of the towers. And it also says the cables touch the road surface at the center of the bridge. Now what we're going to need to do first is draw a picture that represents what is going on here. Alright, so the first thing I've drawn here are the two towers. Those are represented by the red lines. The road surface is the white line. And if you've ever seen a suspension bridge, it's got cables that stretch from the top of the towers down to the road and then back up. So it does say that the suspension cables touch in the center. So I'm going to do the best I can to represent the cables attaching to the top of the towers, but also attached to the road at the center. And then the next, probably most important piece of this particular problem is to lay our coordinate system in a very precise location in order to minimize the amount of work needed. So what I'm going to do is I'm going to locate the XY coordinate system such that the vertex of the parabola is at the origin of the coordinate system. So here I've got my X and Y axis. At this point, we need to label some of the values on the picture. So if we go back and read, it says that the towers extend 65 meters above the road surface. So that's going to give us a height of 65 for the red lines. And it says that the two red lines, the two towers, are 800 meters apart. So the way that I've constructed this, the distance from the center of the bridge to a tower is going to be half. So each one of these distances here will be 400, giving us a total distance from tower to tower of 800. And with this information, we know a couple of things, okay? So let's label the vertex of our parabola is centered at the origin because we chose it. We also know this point on the parabola where the cable touches the top of the tower. So the x coordinate of that ordered pair would be the distance across the road to the tower, which is 400, and then the y coordinate would be the height of the tower, which is 65. If you know the vertex and a point on the parabola, you can construct the quadratic function that represents the parabola. Okay, starting at vertex form, we're going to do a little plug and play. First, we need the y coordinate of the ordered pair where the cable touches the top of the tower. The y coordinate of that point was 65. A is the only piece of the puzzle we don't know. X will be the x coordinate of the ordered pair where the cable touches the tower. So we're going to replace x with 400. H and K are both 0 because the vertex is at the origin. And now we have enough information to calculate the value of A. So that's going to give me 65 equals 400 minus 0 is 400 squared, which I can actually write as the coefficient of A, plus 0 means there's nothing else there. If I divide both sides by 400 squared, that will eliminate the coefficient of A, giving me the value of A. And I'm going to leave this as 65 over 400 squared to make it a little bit easier to work with. Okay, so now we can rewrite our quadratic function in vertex form. That's going to be a x squared. And since h and k are both 0, that's going to be it. That is going to be the quadratic function in standard form. Now that we have the quadratic function, we can actually answer the question they really wanted to know. It said find the height of the cables at a point 200 meters from the center. So if we go back to our picture, we know that 200 meters from the center would be about halfway from the center to the tower. And then if we go straight up to the cable, that would be the y coordinate of this ordered pair having an x coordinate of 200. Do you see that? If I go from the center over 200, that is an x value of 200. What we want is f of 200. We want the function value at 200. And so that means all we need to do is come down here to our function and plug in a 200 and work it out. So once we get that value, we're going to bring up our calculator, making life so much easier with the Casio ClassWiz. And for times, you can either put times 200 squared or you can put parentheses 200 squared. Either way is fine. Now that's going to give us a height of 65 fourths. MyLab Math says the height of the cable is, and it simply says simplify your answer. Well, the ClassWiz would simplify this if it would. This is the simplified form of the answer, 65 fourths. So we're going to input our 65 fourths, and we're done. If you have any questions or comments about anything that I've covered in this problem, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.